I wanna do all the things you lost to so long. I'm gonna bend into you like a cat bends into a demon. Turn you inside out and lick you like a crisp packet. You're the first and last of your kind. I wanna be every leaf that you grow, and all showers that shower you. Gonna pour more at you like a cat pours at my water. Me on min, and go and some trivia.
Alright, let's do some noise exposure calculations. This should be a pretty short video. I've just got a couple of methods that I want to share with you. Again, methods that we may be able to use in our practice. Also methods that may show up on certification exams. The first thing I want to look at here is a method used to calculate how long a worker can be exposed to a particular sound level. This is the formula that we would use. Again, this is the NIOSH formula if we're following NIOSH recommendations. If we're following OSHA's permissible exposure limits, there's a different formula, slightly different. I'll share that with you at the very end of this calculation. And let's say we have workers in an area where the sound level is 92 decibels. How long can they work in that area without making modifications? That's what we can calculate with this formula. We're calculating a length of time that they can be exposed to 92 decibels, or it can be 93 decibels or 97, whatever the sound level is in the work area. Yeah. Let me back up here and talk a little bit about the formula. There's only one value that needs to be plugged into the formula. L, that's the sound level. In our example here, it's going to be 92 decibels. T is the allowed exposure time in hours. That's what we're calculating. So yeah, to do this calculation, write your formula out. Then plug your value in for L. Again, 92 is the value for L. Then we need to do the math. We need to do 92 minus 85 is 7. We end up with 7 over 3 as an exponent. We have 2 to the power of 7/3. We do that calculation, 2 to the power of 7/3. Actually, I divided 7 by 3 and came up with 2.33. So we have 2 to the power of 2.333. When we divide 8 by 2 to the power of 2.33, we end up with 8 divided by 5.0397. When we do that last division, we find that these workers can be exposed to this sound level for about an hour and a half, 1.587 hours. I would round that to 1.5 hours. If the workers need to be in this area longer, they need some protection, some kind of modification, some types of controls will need to be implemented. Either we need to reduce the sound level in the work area, or we need to provide them protection that reduces their exposure. Again, this is the NIOSH formula. Let me go ahead and write that in here. Again, NIOSH, it may have been a while since I mentioned NIOSH, National Institute for Occupational Safety and Health. They provide recommendations, recommended guidelines. employers are not required to follow the NIOSH recommended guidelines. For me, I think it's a best practice to go with the NIOSH guidelines wherever possible. Now, if we don't want to follow the NIOSH guidelines that are usually more restrictive, we can use the OSHA formula. This is the OSHA formula. And the OSHA formula is going to result in a longer allowed exposure for 90 decibels. So, have any questions, let me know. This is a handy formula that may be useful in our practice as a safety professional. It could also very well show up on a certification exam. And on the certification exams, be sure to know the difference between the two formulas. Let's look at another exposure calculation that can be useful. This calculation, this formula, and this method allows us to calculate the noise exposure or the dosage for the worker relative to OSHA's maximum allowable exposures at different decibel levels. This is a table from the OSHA regulations. It shows how long workers can be exposed to different decibel levels. At 90 decibels, workers can be exposed up to 8 hours at 90 decibels. At 92, 6 hours. At 95, 4 hours. 97, 3 hours. All the way out to 115 decibels, the worker's maximum exposure during the workday is 15 minutes. Workers can't be exposed to more than to 115 decibels for more than 15 minutes in an 8-hour workday. Well, what this formula allows us to do is look at their total exposure for different periods throughout the workday, different periods during the workday when they may be exposed at different levels. An example like this, perhaps. In an 8-hour workday, a worker is exposed to 90 decibels for 1.5 hours, 92 decibels for 2 hours, 102 decibels for 3 hours, and 97 decibels for 1.5 hours. What is their total dosage relative to the maximum allowable? And what we're going to calculate here is a percentage of maximum. As long as D is not greater than 100, the worker's not been overexposed. But if D is greater than 100, meaning they've been overexposed, then the employer is going to have to make some modifications. They're going to have to introduce some controls. They're going to have to provide adequate PPE for the workers. Now, to calculate D, we first have to calculate this part of the formula. Summation C sub I divided by T sub I. Summation C sub I divided by T sub I. When this is all spelled out, this is a shortcut notation using the summation operator. When mathematically, when we actually do this calculation, we're working on several terms. We're going to have several different operations that we're completing to come up with this part of the formula. Once we do this calculation, we'll plug it back in to the formula here. Okay, let's go ahead and do a problem where we're calculating the worker dosage relative to the maximum allowed by the OSHA regulations. And here's our problem. In an 8-hour workday, a worker is exposed to 90 decibels for 1.5 hours, 92 decibels for 2 hours, 95 decibels for 3 hours, and 97 decibels for 1.5 hours. Again, that's an 8-hour workday. And we want to know what their total dosage is relative to the maximum allowable. And again, like I said on the previous slide, we're going to calculate D, which is going to give us a percentage value. But before we can calculate D, we need to calculate this term that's within the D formula. So let's go ahead and do that. And when we write out this term, again, this is a shortcut notation. When we write it out, this is what we end up with. There are 4 different exposure periods, so we end up with 4 different terms. C sub I or C sub 1, this term, this is going to be 1.5 hours. That's the first exposure period, 90 decibels, 1.5 hours. Go ahead and bring this one down here again. 1.5 hours is going to be C1. C1 corresponds to this first exposure period. Now T sub 1, this is the number of hours that is allowed by OSHA at a sound level of 90 decibels. Again, 90 decibels, 8 hours. So that's where we're getting T sub 1. So C sub 1 is the 1.5 hours of exposure to 90 decibels. 8 hours is the maximum allowable exposure to 90 decibels. Then C2 is going to be 2 hours. And T2 is going to be the maximum exposure time at 92 decibels. At 92 decibels, workers can be exposed for 6 hours. So that becomes T sub 2. C sub 3 is 95 decibels for 3 hours. So C sub 3 is 3. At 95 decibels, workers can be exposed for up to 4 hours. So T sub 3 is 4. Then our last exposure period, we have 97 decibels at 1.5 hours. So C sub 4 is 1.5 hours. And at 97 decibels, workers can be exposed to that level for up to 3 hours. So T sub 4 is 3. The next step, once we have our values plugged in, 1.5 divided by 8, 2 divided by 6, 3 divided by 4, 1.5 divided by 3. We add up all of these values, and the summation of C sub I divided by T sub I is 1.771. It's greater than 1, so that tells us already that the worker is overexposed. Because when we bring this 1.771 and plug it back into our formula and multiply that by 100, we end up with a value of 177.71, or 177% of the maximum allowable. The worker's exposure level is 177% of the allowable dosage. Measures must be taken to reduce their noise exposure. That could be a variety of modifications. It could be reducing the actual noise that's generated in some way, or it could be providing the worker with personal protective equipment that's going to reduce their noise exposure. And the best method would be to actually reduce or eliminate the noise. But if you can't reduce or eliminate the noise, then you have to go to personal protective equipment. Now, this method could be used if there were only 3 exposure periods, or if there were 6 exposure periods. This method could be used. Now, if the decibel exposure, if the exposure level is below 90, then you're going to enter 0 for C1 divided by T1. Let me go ahead and write that out here. So you have that as a written record. If exposure level less than 90, then C over T is going to be 0. So let's say our first exposure period was 80 decibels instead of 90. Then this first term would have been 0. It would have been 0 plus the rest of them, and then it would have ended up reducing the percentage of their exposure. So let me know if you have any questions. That's it for this short video. A couple of methods that may come in handy and that you may see on certification exams.